Hi everyone, and welcome to our next lesson in geometry. Today we're continuing on with lesson 1.1, but day 3 we're going to talk about angles and finding their measure. So reminder, angles are made up of our rays, and if we look at them on a ruler, a protractor, what we see is these angle measurements, and that's how we can measure the size. It's basically a ruler before our angles. So notice, because we can see either 0 or 180, you'll determine, okay, is my angle look bigger than 90 degrees or less than 90 degrees to help us actually measure that. So for instance, angle AEB, we see touches out here a little bit more than the 45 degree marker, so like 47. Over here, if we go AEC, that's out here by 105 degrees, would be the measure of that angle, so we can actually see those pieces. Now, sometimes we might have to figure out the difference in between them. For instance, BEC then is going to be that 105 degree angle minus that 47 degree angle. So another angle, and again, I like to trace these out. If I look at AEC, again, that was 105. And then BED, this angle here, isn't directly on our starting point, but we can add, because we know certain pieces. We know that AED, this biggest angle, is out here at 130. We also know that we're taking away then this piece that was 47. So 130 minus the 47 degree angle over here is going to give us the angle we want, so 83 degrees. Now, again, some special things we've talked about with angles before. Right angles are angles that measure 90 degrees. So you'll see a little symbol like this to show you that means 90 degrees exactly. Acute angles are angles that are less than 90. And obtuse angles then are going to be ones that are larger than 90, but less than 180. So for instance, maybe this one is 60, but our obtuse angle is 108. Now, what all this is leading us to is similar to our segment addition postulate. We also have an angle addition postulate, which, again, I like to say small angle plus small angle is going to ultimately give us our biggest angle. So in the picture up above, angle CBD plus angle DBA gives us that total angle of CBA, or ABC. Now, when we talk about a point being on the interior, kind of like we talked about points between in the previous lesson, that means that it's going to be on the inside. So if we have angle ABC, like we have up above, point D being on the interior just means it is on a ray somewhere inside of that. So when we draw our pictures, we can see that. So in our first example, again, it's really important that we draw a picture. So this time it says point P is on the interior of angle XYZ. So I'm going to start by drawing angle XYZ. And I know point P is somewhere inside there. Now to label my first part, it says that XYP, so this angle right here, is 25. Angle PYZ is 50. And our total angle then, XYZ, we want to know what that would be. Well, again, we know the small angle plus the small angle is going to equal our largest angle if we add them together. 25 plus 50 is 75. Now, a picture, again, is important if we look at our next example, RTD, because M is on the interior this time. So we have point M somewhere inside. RTM is 40. RTD, this whole angle here, is 65. and we want to find MTD. Well, similar to with our segments, sometimes we need to do big minus small to help us find our other small. In this case, that would be 25 degrees. Try the next two examples on your own. Make sure you label and find the measure of WBD. Try number 2 then. Measure and find angle FGC. Now, a couple more examples. This next one wants us to find multiple angles, X and Y. So we need to, again, think about our angle addition postulate. This time they gave us that this angle is 57, and we're trying to find this little angle down here, angle X. Well, one of the small angles is 22. So if we take 57 minus 22, that's going to give us our value of X, which is 35. So we know that's the value of X. And then same kind of idea right here with Y. If our whole angle is 74, and we know this part is 57, we can again subtract 74 minus 57 to get our third remaining little guy, which is going to be 17. So sometimes you might have 1, 2, 3 angles to add up to equal our biggest angle. That works as well with our angle addition postulate. Now, of course, we sometimes need to bring algebra into the fold. Okay, so again, if we take this picture here and draw it, this time it's telling us that H is on the interior of our angle, and we have EFG as our big angle. Okay, H is on the interior. EFH, this little angle here is 75. HFG, this angle here is 10x. And then the whole angle, EFG, this big angle here, is 20x minus 5. And we want to find two pieces. We want to find either our value for x. We also want to find the value for HFG. So in order to do that, we need to add our small angle plus our small angle and equal it to our big angle. And then we do some algebra. Again, 10x is smaller than 20x, so I'm going to subtract that over. So we have 10x minus 5. Add the 5 to both sides. We get 80 equals 10x. And when we divide by the 10, x equals 8. That's part 1. Part 2 then is to find HFG, piece here with 10x. So we're going to take 10 and multiply it by our x value of 8 to get our other answer of 80. Try this next one on your own. First, find x, and then make sure you plug it back in to find EBC. Be sure to label your picture. Now, there's a little bit more vocabulary down here at the bottom. For instance, complementary angles are angles that add up to 90 degrees. So 50 plus 40 or 30 plus 60, those would add up to be 90. Supplementary angles are when our angles add up to be 180. So 130 plus 50, whether they're next to each other or not. Speaking of if the angles are touching, like this example here, that is known as adjacent angles, and that happens when they share a side and a vertex, like this piece here. And a linear pair are when we have an adjacent angle that's also supplementary. So you would be adjacent and supplementary. That's going to be our linear pair. So a couple more examples. If we see this keyword of complementary, we know that those two angles have to add up to be 90 degrees. So we can take these and add them to equal 90. Now again, in solving, be careful to condense first. So we have 6x plus we also have 25 plus 11, so 36, and that equals our 90. Once things are condensed down, we can subtract, and then ultimately we can divide so that we get an x value of 9. Now notice it wants the measure of each angle. So we're going to plug back in to angle L first. 2 times 9 plus 25 for a total of 43 degrees. And then we have a total for angle M. We're going to take from, again, up above here, 4 times our x value plus 11. So 36 plus 11 is 47. Now that makes sense because if we add those two numbers together, they again equal 90 degrees. Now, the next piece here, notice they're giving us two different things, 5x plus 68 and 9x. And together, they're creating what we saw on the last page, this idea of a linear pair that are creating a straight line, aka they have to equal 180 degrees. So if we add these two together, we have 5x and 9x, so 14x's, plus our 68 equals the 180. Subtract that 68 over, get 112. And when we divide by 14, x equals 8. Now be careful what this question is asking us for. CEB is this angle right here. They didn't give us something to plug back into for CEB. What they did give us, though, was its linear pair pal, AEB. So if we plug 8 back in here, we see this is 72 degrees. And then we know that these two are creating this straight angle. So 180 would be the size of our big angle. Subtract away the 72. We get a total of 108. So this is a really nice example for being careful of what the question is actually asking you for. Last but not least, you try this last one on your own, similar to this example up here. This time, though, you are just solving for x. Thanks, everyone, for watching, and we will work more with this in class.